Welcome to the eLABorate Topics podcast, where we focus on lab-specific strategies for medical laboratory professionals. We're proud to be the healthcare detectives that work behind the scenes to get the results needed to influence medical decisions. Let's grow together and jump right into the lab.
Welcome to another episode of eLABorate Topics. I am your host, Lona Small. eLABorate Topics is a weekly podcast where myself and my co-hosts, Taiwana Wilson and Stephanie Whitehead, come to bring you topics to help you to excel both inside and outside the lab. So today I'm really excited because I'm going to bring to you one of those topics that we don't talk about routinely when we're talking about lab, but it's something that happens to us on a daily basis, and that's patient safety and lab errors. I know, not a really sexy topic, but an important one. So just, asking, have you had a lot of patient safety errors that you find yourself investigating and coming up with solutions, and then they just keep popping up again? The same exact error keep popping up again. And of course, I'm raising my hand because I've been there. And over the last, say, 15 years of my career, there was a standard way in which we would investigate, and we're trying to solve patient safety or lab errors. And usually what we'd do, if there's an error, we'd try to find out who was involved. And once we find out who was involved, then we'd look at what happened and how did it happen. And then once we find that out, then we'll say, okay, how do we prevent this from happening again? We'll get who was involved, and we'll write up a remedial training, and we'll go ahead and we'll retrain that person, have them signed off. And what if it happened again with that same person? We'll go through the drill, who was involved, then how did it happen, what happened, remedial training. And if it keeps happening again, of course there's enough paperwork that that person can either be suspended or that person could be fired. And in situations where an error happened, and this is the first time it's happening for this particular person, and if we know that this is a good tech and it's happening for the first time, then we would start, okay, so what happened? Was she sick? What was happening when that happened? Was it really busy? It's very unusual because she's a good tech, and there may be time when that person may get retraining depending on what happened, what was surrounding the error, because if it's a good tech and it's not happening for that person over and over, we don't want to have a blemish on a good tech's name, so we may write them up. But what if I write up a good tech and then I find that it's happening again with that good tech? Then it becomes almost mind-boggling and what's really happening? And what if that error affects another department? Say, for instance, the ED, then, and they're saying that this is a major issue, then the next step would be, let's make some changes. Let's make some changes on our side. Maybe we need to rewrite the procedure. Maybe we need to send out a memo. Maybe we just need to change something and, let the ED know that we made some changes, and, things should be fine now. Of course, there's a new policy. There's a new way to do things. And after seen this for over and over, in different institutions, different labs, over and over. What I found was that the errors didn't go away. Of course, what I mean is that the exact same errors that we retrain somebody or we write up a new memo, we find that the errors keep popping up. The same errors keep popping up. And it was not until I understood system thinking then I realized that approach, when you're approaching things in silo, especially when it's an error, that will not fix it. And if you're just taking one element out of everything, like pulling out a people and say it's a people problem and fixing the person, it won't fix the error. So understanding system thinking helped me a lot, because what you're going to see with system thinking, there's just so many different factors that's involved in the system. So there are people that could affect, cause an error or affect the way things are done. There's a structure, that's the way things are set up, the environment, the culture, the care team, the actual patient. There are just so many factors that are interconnecting and interrelationship with all these different factors that can cause an error. And so just pulling one thing out and trying to fix that one thing, many times it's just a lot of work, and many times a lot of energy that's spent and would not resolve the problem. So today I'm going to talk just a little bit about system thinking. So as I mentioned, system thinking is a way to approach any kind of problems or solution by looking outside of your own area, outside of the lab, looking at all the different things that are interconnected that could result in something working very well or something that would not work so well. So it's important for me, what I realize is that you don't have an error-free lab, right, by working hard. Like, you're working so hard, you're training people over and over again with the hope to have an error-free lab. That will never happen. Another thing I realized is that unless you do a root cause, like find out what really is wrong that caused the error, just retraining someone, unless you do that root cause and you found out that that person was not trained initially, or the training process that was involved in that initial training was inadequate, then retraining someone will never fix the error, unless the problem was training in the first place. So you train them so well, and then there's another error, you go back and train them again. Think about it. Training will not fix an error. So for people who have that as their process, when there's an error, to do a remedial training, that will not fix an error. And I had to find that out, of course, through a lot of training as a patient safety expert, but also through experience. And then another thing I found out over the years with training and experience was that most errors are a result of the design of the system that the error takes place in. So we talk about system thinking, that there are people, there's process, there's environment, there's all these. How is it designed? Is it designed in a way that will create an error? Is it designed in a way to reduce error? So when you think of an error, think of the system design. So it's important also to work with others in other parts of the system, because the lab is just one little part of a whole system. So the lab is one part of the structure, but then you have to think about how the whole, the hospital is structured, the clinic is structured, that involve the ED, the lab, radiology. So that's just one area. So it's important to work with others in other part of the system to understand their process before drawing any conclusion about how to improve the system. So, of course, many errors can be reduced by improving the way the system is designed, but improving just your area is not going to improve the whole system. And so it's important to work with other people in other parts of the system. So improving the design could involve improving people, process, culture, environment, infrastructure, and how they interact. So you don't just fix, as I said, I don't fix my area and expect that will fix the problem. So just go in and say, okay, I'm going to just fix my procedure because there was a major problem in the ED, so we're going to fix the way we do things, and this should fix it. That usually does not happen. So use ED as an example. So there was an error in the ED. Say there was a tech, so there was an error that involved a tech. And the tech probably was trying to call a critical action value, and the critical action value was not called to the ED in a timely manner. So when you investigated it, you found that the patient was a trauma patient, so the patient is also part of the system, and the providers were busy and no one was able to accept the critical action value, right? So in that case, there's so many different things involved. So you have the providers involved, you have the patient based on what's going on with the patient, you had a busy ED, you have a tech involved. So when you start looking at the system design, you're going to start asking, so what was going on with the patient? Like the patient condition, age, family, how did these factors affect what happened with the error? Then when you start thinking of the organization, which is part of the system, you start thinking it was the ED and, how are things done in the ED, could affect or impact or cause the error. Care team, what was going on with the care team? Their availability, was there adequate staffing, was there customer service involved? That's another factor. When we talk about the environment, environment could involve like regulatory environment and rules in the lab. So CAV guidelines, the time it should be called, like there be a turnaround time? Is there any regulation to who it should be given to? All of those factors could affect what happens. And I mentioned this as a scenario, but this was actually a real-life example, but there's so much more to that example. But instead of just going into the detail about that example, I just wanted you to think about some of the factors that could affect the error. So what I'd leave with you is just a few steps, that things to consider whenever there's an error. So it's important to consider system. Start thinking system thinking. Think about system design, like what we spoke about just now about the care team, the patient, the environment, just general things like those, the organization structure. Think about those things. So that's kind of the first thing. Then you're going to talk to your team to understand all these possible system design factors that could cause the error. So you have your own team. You're gathering data from your own team. But then the next thing to do is to meet with the other care team in the other part of the system outside of your team and try to understand what's going on with their part that could also affect or cause the error. So it's not just in one area. It's a whole interrelationship of different factors that could cause an error. So meeting with the other care team is important when you're gathering data on your side, data on their side. You sit down and discuss your findings with that group, and then as a team, you can identify any flaws in the system that could cause the error. And as I say, in the system, you could be looking at people, you could look at process, infrastructure, culture, workflow, any flaws in the system that could cause the error. Then, after then you can start discussing solutions. And discussing solution, you're discussing solutions as a team, not just your team, but with the other stakeholders that are involved. So that's when you start discussing solution, understanding how any change could affect each area. So one area change on my area could affect the other area. So there are unintended consequences that could happen as a result. So you go ahead and just change your policy and procedure without understanding how it will affect the other area. You could be creating another problem, unintended consequences. So you discuss your solutions, then you make your changes, and you monitor the change, because sometimes you may not be aware of all the possible consequences. So monitor these changes. So that's when, if the error is reduced, then you can create a permanent process change, a new procedure or policy, and then you still continue to monitor. So I gave you 8 steps, and I'm going to put that in the podcast notes. So your first thing you're doing is consider system design. Then you're going to talk to your team to gather data. Then you're going to meet with the other care team to understand their process and their system, how that would affect the error. And then number 4, you're going to discuss your findings as a group. Number 5, you're going to identify any flaws that you identify as a team, and that could be people, process, any area of the system. Then number 6, you're going to discuss solutions and understand how any of those changes could affect each other. Think about unintended consequences. Then you make your changes, monitor before you put things into a permanent procedure, policy, and continue to monitor. So that's what I wanted to talk about today, to have us thinking outside of the box, outside of being siloed, outside of just thinking, I know what the answer is, and it's that person, and that person continue to make that error, and help you to think that continuing to retrain will never get rid of a problem unless you identify retraining, lack of training in the first place, as one of the root cause. So one of the first things I like to give one thing to do when you leave. And I know it's a lot when I think about, if you're going to go through this, just like start thinking, system thinking, it's a lot to do. So the first thing that I would do for people, especially who are not used to stepping out of the comfort of the lab and working with others outside of the lab, one thing I want to let you know that it's important to realize that you cannot have an error-free lab. So don't get frustrated, even if you are looking at system design and trying to improve your design. You may improve the error in that design that you identify, but there may be another flaw somewhere else. So there's always opportunity for continuous improvement. And so I have a free gift for people who are uncomfortable going outside of the lab. I've mentioned this before because I really encourage lab working together with other healthcare teams to create visibility. So I have a free gift, which is 5 baby steps outside the basement. And they're just really tiny things that you can do to feel comfortable working outside of the lab and working with other healthcare workers and trying to create change and trying to improve some of the safety issues that we have in the lab. So for people who are not used to doing that, that's my gift to you. And hopefully we can just take these baby steps and start working outside of the lab. So that's all I have for today. Hopefully you'll use this. Go ahead and check it out on directimpactbroadcasting.com, where you'll see the podcast note where I'll have all the steps for you. And you can also grab your free gift there. So until we talk again, check us out on directimpactbroadcasting.com. You can send us an email if you have an idea of a topic that you'd want to hear us discuss. You can send us an email at eLABorate@directimpactbroadcasting.com. And you can also send us a message if you want to be a guest on this show. So until we talk again next week, have a great one.
Thank you for tuning in to another episode of eLABorate Topics, where your hosts discussed relevant strategies for laboratory professionals. Please subscribe to this podcast on your favorite podcast platform and listen to us on directimpactbroadcasting.com. Stay tuned for another episode with information you can use to excel in your laboratory career.